I'm going to talk about cookies today, and so let me just first introduce myself again, very shortly. My name is Max. I'm originally from Russia. I'm living in the Netherlands right now, and I work with Surfly. We're working on the sandboxing proxy. So it's a great place to be if you're like me, if you love the web, and if you're ready to learn it the hard way. And one of the things that I've been working very closely in the last few years is cookies. So cookies are, as I learned, they are ancient. The first RFC was introduced in 1994, I believe. They're also sophisticated. There is a lot of intricate details to them, and actually sometimes so much that they just don't make sense. And in this sense, cookies kind of remind me of this thing called Zen Buddhism, which, hence the name of this talk. So, and this talk is going to be basically just a collection of pitfalls and examples to kind of prove this statement that cookies are like Zen. Because, there are much more clever people than me working on cookies standard in web standard space. But us ordinary web developers, we don't get to deal with corner cases so much. So when we do, like for example, if you need to implement a GDPR compliance, like some cookie wall solution or something, we often get nasty surprises. And so another goal of this talk, I guess, is to kind of raise awareness about this trickiness. So hopefully it will be a heads up for folks out there. And finally, I think some people might just find it fun, just like I did. And yeah, so let's get to it. So this is how Mgm defines cookies. It's a small piece of data that the server sends to the user browser, and browser can store it and send it back. So basically, we're introducing state into a stateless HTTP protocol. And I'm assuming everyone knows this to some extent already. But for the sake of this talk, let's just extract a few facts about cookies. Fact number one: cookies can be set with set cookie response header or JavaScript API, namely document.cookie. Fact number two: cookies require special string format when setting. And three, browsers send cookies back to the site that has set them. And finally, fact number four, everyone knows it, that cookies are giving you the best online experience. Man, making jokes to an online audience is weird. So if we rephrase this, what it really means to us developers is cookies are most often than not sensitive. So they should be protected, and you don't want to leak them in most cases. So I suggest to we make these four facts our agenda for today, because each of these points is a rabbit hole of its own if you look closely enough. And starting with the first one, so let's just start by saying that set cookie header and document domain are not the only ways to set a cookie. We have browser extensions, and browser extensions have this pretty powerful cookie API. It is asynchronous, pretty much solves all the usability problems that document cookie has, and it's actually great, and it's much more powerful. But to have this power, unfortunately, you have to have an extension installed in the user browser, which is not necessarily simple. Another way to set a cookie is this. Now, I think most of the people, they have never heard about this, but there's actually this special meta tag that you can use in HTML to kind of emulate the HTTP headers, and you can set a cookie with this. Now, this feature has been actually removed in Chrome and Firefox, well, not so long ago, just last year. So you can't really use it on the web right now, but well, you know, some browsers still support it. Yeah. So let's talk about JavaScript, right? So you can use document.cookie. It's a JavaScript API to read and set cookies. And apart from the fact that it is synchronous, so it actually introduces quite a lot of performance problems, it's also quite peculiar in a way that, well, just look at it. So the setter is actually using completely different format as the getter. It's string format, but the actual values are very different. And the value of the return value of a setter, it seems like it's always the same as you have said, so it's completely useless, and it doesn't raise any errors if you provide some malformed data. So, for example, if you want to verify if your cookie has been actually set, the only way to do that is to read it again, parse that different format, and then check if the cookie is there. And this inconsistency actually causes a very interesting problem. So look at the getter format. This is the same format as you will see in the cookie header in the request. And if you think about it, once a cookie has been set, this is the only information your web application will ever get back. So just the name and the value of all the cookies. So if you ever want to check the, for example, an expiration date on a cookie of existing cookie, or its path or domain, there's just no way to do that. You just need to know it in advance. And this creates, so for example, let's say if you have a cookie that has been set, for example, some library, Google Analytics. So you're reading the cookie, it says cat equals dead. Let's say we want this cat to be alive, and we are overwriting this cookie like this. Then we read it again, and we end up with two cats. Why? Because the first cookie was set with the domain attribute. So this domain attribute actually changes the scope of these cookies, and when we try to override it here, we actually created a new cookie with the same name. But unless you know how the initial cookie has been set, with which particular attributes, you have no reliable way to override it. And well, you just need to know it. So as weird as it seems, even if you have full control over your web application, you don't really have full control over its cookies. You can do this with a browser extension, but again, that's not always possible. Going to the next step, let's look at the setter format, right? So you have seen this before, probably, and well, this is actually quite nice, right? So you can look at it, you can read it, you understand what it does, but you know, human readable is almost always the opposite of machine readable. So the problem is that this exact cookie could be set by hundreds of different ways. Like, for example, you could do this. This leading dot in domain attribute doesn't actually change the semantics. And you can play with white spaces, add them almost everywhere, remove them. You can play with character case and get creative with some values. Or you can even get on the bleeding edge of the technology and use cookie prefixes. This is my favorite because it's like an AI of the cookie standard. So there are reserved cookie name prefixes that browsers respect. And for example, this one, you wouldn't be able to use it without a secure flag because browser will not allow you to. So, and we didn't even get to the obviously wrong, but well, still valid formats like this or like this. Notice the multiple path attribute. So there is quite a few places to get confused. And if you're curious, there is a very nice research by Van Nikulin over here. He is comparing the parsing differences in different browsers. And well, believe me, it's quite a mess over there. So at this point, you might think, okay, parsing is very tricky. I shouldn't do it myself. But surely enough, every decent programming language has a library that does it, right? And you would be right. There are hundreds of implementations over there. But the problem is that they're all wrong. Or they're all right, depending on how you look at it. So for example, Python has this built-in HTTP cookie module that can parse set cookie format. But as long as you start passing something not very standard, like this, it falls short. So for example, this string here, it would be interpreted by a browser as a single cookie named A, and everything else would be its value. But this library interprets it as 3 different cookies. And so imagine if you start using this library in some kind of HTTP proxy. So you would be quickly messing up the responses and possibly even introducing vulnerabilities in your application. Another example is cookie folding. So actually in the earlier standard, this was allowed. So you could set multiple cookies in a single set cookie header, divided by commas. So this is not supported anymore, but Safari was supporting it up until 2 years ago, up until macOS Sierra. And you can still see it in the latest dev tools in Safari. This header would show up like this. So as if there were 3 different cookies set. And well, even though only the first one would be actually set and stored. But so now, what I'm saying, nowadays, major browsers don't support this anymore, but the problem is that library implementations still do. I would dare to say that most of them still do, because at some point it was allowed actually, but they never changed the implementation. And if you Google, there are quite a few bug bounty reports with real vulnerabilities exploiting this cookie folding. So parsing is very tricky. And let's just look at a few interesting examples. So did you know that you could have a cookie with an empty name? So this one here is an empty cookie with an empty name and smile, and it would show up without an equal sign in a cookie header. You can of course have a cookie with an empty value. That's okay. You can use special characters. Most of the cases, cat exclamation mark is a valid name. You can use equal sign multiple times. In this case, this is a single cookie named A, and B equals C, etc. is its value. Sorry, and you can use white spaces, as we told before. And finally, you can play with encodings. So the current standard actually allows only a subset of ASCII in a cookie value. However, most browsers actually allow Unicode, like UTF-8. And so this is the difference between actual implementation and the spec. And there is a work going on to actually change the spec to conform with actual de facto standards. Even though, well, I would say that this is weird by itself because you don't normally see Unicode characters inside HTTP headers. But anyways, so this brings us to the next stop. Browsers send cookies back. So what I'm going to talk about here is cookie scope. Cookies have these attributes, and name, path, and domain are special because they define the cookie's identity, which means that all these cookies here, despite they all have one and the same name, but because they have different combination of path and domain, they're all considered different cookies. So this page here would actually receive all of them at once. And as we told before, the server would have no idea how to distinguish between those cookies because all it gets is names and values. An interesting thing is that the order of the cookies in the cookie header is actually defined. There is an algorithm, but it's quite complicated and counterintuitive, so I wouldn't really rely on that because why? So going on, we know that the cookie scope is defined by the URL, right? So this page here would see the first cookie, the oatmeal, but not the chocolate cookie because the path doesn't match, right? So this is okay, reasonable. So what if we do this? We change the document URL with history API, just like single page applications do, right? So the document URL will change, but should the cookie change? Should this practically the same page, should it see different cookies? And the answer is it actually shouldn't. So this kind of reveals that document URL and cookie URL are different things for a browser. And yeah, so the cookie contents will not change. However, if you thought that it should have changed, you're right too, because in some browsers, it's actually, it would be changed. Okay, so now we know that document URL and cookie URL are different things. Let's go deeper. What do you think the behavior of cookies will be inside these iframes? So you have a few empty iframes, these are CDoc, and a few special schemes, blob URLs, file, and data URLs. And well, don't even try to guess. There is no correct answer. All the browsers think differently. So sometimes they would inherit the parent scope, so the scope of the embedding document. Sometimes they would just simply ignore cookies inside these iframes. And in this case, in case of data URL, Chrome even raises exception when you try to set a cookie. And this is actually the only case that I know that where you actually get an actual exception when you start to set a cookie. So it's like a wild west, really. Speaking of compatibility problems. And this brings us to the last topic, which is security and privacy. Now, this is a very broad topic. Like, I mean, even defining what privacy means with regards to cookies is very difficult. You might know that each browser has its own approach to tracking cookies, for example. And the definition of tracking cookies is different for browsers. So Safari has this intelligent AI-backed ITP system, and Firefox seems to use like blacklists, whitelists of trackers, etc. So it's a broad topic, but I do want to touch upon a few things that I think are very good. It's very good to know for every web developer. And first of which is weak integrity. So consider this. Any page can set a cookie with any arbitrary path. So if this page sets this cookie, then Jimmy will not actually see this cookie back, but Chuck will see it on every subsequent request. Which, so the takeaway here is that, well, path, even though it's kind of isolating cookies, but it shouldn't be considered a security boundary because you can still override other paths. Same with domains. Domains can set cookies on any subdomain of theirs. So google.com can set cookies on mail.google.com. And if this looks okay to you, so consider this. GitHub.io, if you use GitHub Pages, GitHub.io can set cookies on any actual GitHub Pages domain. But it gets better. myevilapp.herokuapp.com could set cookies for all other herokuapp.com domains, just by setting this domain to a super super domain, so to say. So this would affect all other Heroku apps if herokuapp.com was not a public suffix. So actually, Heroku is specifically safe to use, but not because cookies are safe, but because Heroku did steps to make it so. So herokuapp.com is actually not a domain of its own, but it's just like .com or .co.uk. It's a public suffix, a top-level domain that you cannot use by its own. And that's what's saving us. But if you're ever offered your own subdomain on some random hosting, well, this might not be the best idea, actually, both for you and for this random hosting, for that reason. As an icing on the cake, insecure, unencrypted HTTP pages can override secure cookies that were set by HTTPS pages earlier. So secure cookies are actually secure in a very narrow and specific way. So you should keep that in mind. HTTP-only cookies, luckily, cannot be overridden from JavaScript. But again, if you set a cookie in JavaScript, then the server wouldn't be able to tell if it's HTTP only or not, because it only gets the name and the value. Last thing I want to talk about is same-site cookies. So this is a recent, relatively recent change, and you might have seen some warnings in the latest Chrome because they're changing the default behavior. So same-site is a kind of a special flag on a cookie because its effect depends not only on the target URL, but also on the source URL. So if one site makes a request to another site, then this request might not include some of the cookies depending on the same site attribute. And so this is basically a security measure against cross-site request forgery attacks. And but the tricky thing here is that, well, how do you define cross-site? What is cross-site request? So when I first heard about it, I immediately thought about same origin policy, right? So most of other security mechanisms on the web, they operate on this, on origins, which is basically a domain plus port and protocol. And origins are isolated from each other. But as we know, cookie scope is very different, right? So the cookies don't really look at the protocol, they don't look at the port, but they take path into account and domain. So given this, which part of the URL do we need to look at to determine whether a request is cross-site or same-site? So I don't know if it's intuitive for you, but it's actually this. It's a so-called registered domain, which consists of a top-level domain, .co.uk, and one part to the left of it. So as long as two URLs share this part, they're considered same site, which means that bank.com can indeed protect itself from evil.com because this is a cross-site request. However, this is a strictly same-site request. This is a strictly same-site request, and even this is a strictly same-site request. So even though all of these are not same origin requests, which means that, for example, you won't be able to send AJAX requests with credentials in all four of these cases. But things like link navigation and form submissions would actually include all the cookies, including same-site cookies in these three green cases. So keep that in mind if you're going to use the same site for protecting against those attacks. Yeah, so cookies are tricky, and but is there any hope? And so Well, unfortunately, as Simon already mentioned, backward compatibility is a problem. So making cookies robust and secure without breaking whole lots of existing cases is very difficult. And while we do see changes, like for example, the same site attribute, it's, well, pretty easy to see how imperfect those solutions are and how clunky and unintuitive they are. But what is not so easy to see is that, well, all these decisions, they're actually a result of months of hard work of truly brilliant web engineers. And those people, they have like tremendous responsibility before the whole web community. And if you are interested, there is, of course, a lot of ongoing work. For a short term, you could look at the latest draft for the next RFC. So this one is actually mostly focused on, reducing the gap between implementations and the spec, just like this UTF issue that I mentioned. For like middle term solutions, there is an interesting proposal from the Chrome team. It's called Cookie Store API, and it's basically an asynchronous asynchronous alternative for document cookie. And we might see it in the origin trials, at least in Chrome, sometime soon. And for like more of a longer term replacement, there is an interesting proposal by Mike West, who is actually the editor of the current standard. So this guy knows what he's talking about. It's called HTTP state tokens, and basically he's trying to take the most common use case of cookies, which is sessions, and he's trying to bake it into HTTP with security in mind. So that's interesting. And all this work nowadays, it's all done in public, right? Which means that anyone can jump in and try to make it better and contribute, which, well, I would encourage all of you to do, because, I mean, like, someone's gonna ask why, like, we're going to use it in our day-to-day job anyways. So, and while it's still in development, it's much easier to make changes to it. And if we're going to use it anyways, why not just go in there and, well, trying to make it better for us? And yeah, so I'm just encouraging everyone to just go out there and take a look. I'm sure you will appreciate the web even more after that. And probably the guide that Simon has been talking about is a good start, because, well, I had a look at it, and it's a gold mine of useful links if you're interested. So go ahead and check it out. Yeah, so that's pretty much all I have for today. And I think the only thing is left is a cookie monster that ought to be on every cookie presentation. And if you have any questions, I'm just happy to answer them.
Thanks a lot, Max. Yeah, it's always interesting to hear these corner cases. Some of them are really insane.
Yeah, they are.
The port one always is bizarre to me. So we actually had a question somewhere in the middle of the talk. Why are they called cookies? Do you happen to know offhand?
Oh, well, actually, I'm not sure. I mean,
Simon?
Yeah, maybe Simon would know.
I don't really know, actually. I don't know the history.
I happen to know this one. So the old school kind of architecture side term, like software architecture term of a magic cookie as some value that is known and is passed unaltered between two parties that are communicating, or saved somewhere as like a stack protector or something like this. Yeah, it's a magic cookie for the web. And so the original implementation called it cookies because it was the same idea in a different platform. So other questions? We don't have any other Zoom questions. for the cookie talk. But what I'm kind of interested in is the what has the Chrome team proposed for their cookie store API? Is there anything like fundamentally different about, other than the asynchronicity and the, I don't know, more modern API? Does it change the way that the cookies are sent back and forth, or how does all this work? Is
Yeah,
it just
that's
a
a good
browser
question.
API?
Thank you. So so basically, this is why it's still controversial, that proposal, actually, because so what it's trying to do is trying not to change the security model of cookies. So it's mostly a replacement for existing document cookie mechanism, but it's asynchronous. So, and it's inspired by local storage and session storage. So you could subscribe to some events, or you can set and get values, and but it doesn't aim to change the security model. So all this weak integrity stuff is still there. And one more thing that it's adding support for service workers, and because right now it's a little difficult. So I think it's actually one of the main goals to support cookies. And right now you can do this, but you have to make hacks around it, like with iframes that redirect weirdly to something else. So you can already do that, but it's just so inconvenient. So they're kind of trying to codify it and make it better. And of course, performance is another reason, because the current API is quite well, it can introduce junk because it's synchronous, and a synchronous API would solve this problem.
Thank you. I now see, I didn't scroll down, so I was missing a couple of the questions that we had in the Zoom Q&A. So the first one's actually something you just mentioned, which is a question by Peter. It sounds like cookies are almost dangerous. Is there any thought of deprecating them in favor of a more predictable mechanism? And Peter suggests brownies. But yeah, this is the same idea. You said that if the Chrome cookie store API doesn't change the fundamental security model, is there another proposal that does?
Yeah, well, not that I'm aware of, because I mean, cookies are tricky, but they're so fundamental to most of the interactions on the web right now. So they're not going anywhere anytime soon. And while there are those proposals, like this HTTP state token is interesting, but it has its limitations, and it's just a proposal. So I don't think we'll see it in the coming years, I think. Yeah, so we're still good with the cookies. And of course, like my guess is, well, probably Simon would know better, but my guess is if we go forward with that, then it will probably be something completely new, but the cookies will still be supported, and new applications might start using something, well, more structured, so to say, more secure. But yeah, the cookies will not be replaced for a long time, I'm afraid, completely.
Yeah, I think that's right. I think that people can do to have a stricter subset of cookies is to use the same site. I think strict is a value that you can apply it for the same site attribute. I don't remember what the behavior is, but
yeah, that's right. And so browsers seem to be also making steps towards it. So for example, this latest changes with same site, so default behavior of same site cookies, of same site attribute and cookies inside Chrome will be different. So it will be lax by default, which is not the not the most relaxed. Um,
Yeah.
yeah, so I guess the biggest problems with cookies right now is this tracking and all these vulnerabilities that you could have. And so they're kind of trying to tackle the most critical issues with cookies by introducing these kind of things. So the same way HTTP only and secure flags were added back in the days, just like as a backwards compatible change that would still allow to, well, protect the most critical cases. So and this is the whole thing. I think about the modern webs, that it's just it has a pretty long list of old protocols and mechanisms that we can't just drop.
Yeah, don't break the web.
Yeah.
So we have two other questions. We're getting close to time, but they're both really good. So the first is from Ishta, who asks if there are any tools that are there any tools to find out if the way we're setting or using cookies in our domain is exposed to vulnerabilities or exploitation?
Well, this is tricky because, well, actually, DevTools is with regards to same side. Chrome DevTools are already making warnings, but in general case, the thing is that it depends, because what is a vulnerability for one cookie is not a vulnerability, is a feature for another one. So, for example, if your goal is to track a browser across different domains, then exposing this cookie to third-party cookies, third-party domains is okay, and that's actually what you want. But if it's not your goal, so it depends on the semantics of your application, I guess. I mean, of course, the general guidelines is that, well, use the strictest settings as possible. Like, use HTTP only if you only need it for the backend. Or use secure all the time if your website is only talking HTTPS, which it should. So these kind of things, and use same site again for by default. Maybe use same site strict unless it's needed. So I think that's the best way.
Yeah, I don't have experience using tools to check for cookie vulnerabilities. But I just Googled, and it appears that there are tools that try to find problems with cookies. So if anyone has experience with any of them, please share.
Well, I do actually have experience with, like, I'm not sure if this is what you found, the like security scanners, but they're pretty generic. Like, so what the best thing they can do is they have this database of commonly used cookie names. So, for example, I know Django is always using CSRF cookie as a name for CSRF cookie. And so it just knows that, and if it sees that this cookie is exposed or has a very long expiration time, it would just bring a warning. So that's like the most useful result you can get. And of course, you can have like the low priority issues for like cookies if they don't have HTTP only, but they seem to be transferred only with HTTP or something like that. So yeah, like this kind of checks you can do with automated tools. But I think at the end of the day, it will probably just come down to your particular application.
And we're got to keep it kind of short for this last one, but there's a question from Moritz asking if cookies are so complicated and so many legacy issues, should you use local storage where applicable, also for secret values?
Oh, well, if you can, if that actually satisfies your need, I would say go for it, because not only it will be more performant because the local storage contents is not sent with each and every request, and with cookies it is. And actually, we've seen literally megabytes of cookies in a single request. It's not uncommon. But so it's of course it's very bad for performance. But yeah, like cookies are still sometimes needed. So for example, for session cookies, you can't use local storage. Well, I guess maybe you can come up with some kind of mechanism, but it's just not very standard. And simple cookies like session cookies are totally fine because they're usually small and sufficient.
One aspect for local storage and how they differ from cookies is the scope. So local storage and the other storage APIs use the same origin policy.
Yeah.
So they don't use the weird cookie scope.
Yeah, which is, I would say, it's a good thing actually, because it's it kind of plays well with all the other, like with cores, for example, and stuff like that. So yeah, but there are fundamental differences, of course.
Tomas on YouTube asks as a follow-up, isn't local storage more vulnerable to cross-site scripting?
I wouldn't say so. Like if you have cross-site scripting, it's not, I mean, there's a lot of other things you could do. Of course, you would go for cookies most of the time. But yeah, like it's a tricky question. By itself, it's not, because you can, if you have access to JavaScript scope, you can read both JavaScript cookies and local storage. And if you don't need something that, if you don't want to expose some data to client side at all, then why using this at all? You could just store it on the server side in the session storage or something like that. So I'm guessing that if you do use local storage, that means you do want to deal with this data on the client side in JavaScript. And most of the time, actually, I would argue that nowadays, most of the time, the things that you would store in local storage would be, well, quite large for setting in a cookie. So yeah, I think. Yeah.
Very good. Well, thanks for the answers. Thank you for the talk as well. Super entertaining. And yeah, it seems like it generated a lot of interest with the good questions. So